Okay, students, we're going to go over your retake practice. For those that need to retake it again, showing you how to do it. All right, elimination method. We have to eliminate either the x's or the y's. If I want to eliminate the x's, remember I have to get to the opposite numbers. So 6 and -6. So if I would have to be 6 on the top, multiply that whole row by 2, -6 in the second one, multiply that row by 3. So I have to multiply both rows. So if I want to eliminate the y's, I only have to get to 2 and -2. So I'd only have to multiply the bottom row by -2. Okay. And then I get 4x minus 2y equals 14. Make sure you distribute through all three terms. If you draw arrows, draw arrows. Okay. If you want to write this top one down again, and we add straight down, it wipes out the y's. I get 7x equals 21. Divide by 7 on both sides, and x equals 3. Okay, so now I plug that back into one of the equations. I'll just use the top equation. So I have 3 times 3 plus 2y equals 7. 9 plus 2y equals 7. Subtract the 9 across. I get 2y equals -2. Last step, divided by 2, and I get -1. So the point will be 3, comma, -1 is where those two lines intersect. Remember, these are two lines. We're finding the point of intersection when we're doing elimination method, substitution method, or graphing method. Okay. Number 2, substitution. It says y equals -2x. Whenever I see y, I can plug in -2x. I see a y right there. First, I'm going to change that to a plus. So now I have 2x plus 1. Whenever I substitute in, I put parentheses around it. It's 2x equals 0. Then I get 2x, and 1 times -2x is -2x. So I get 0x equals 0. Well, 0 times what number equals 0? Every single number. So x is all real numbers. Okay, which then makes y all real numbers. Okay. Which means that they are the same line. Okay. So if I solve that bottom equation, I get y equals -2x as well. They're the exact same line. All right. Substitution method. Now that may not come out like that on your test, on your retake, but that particular, otherwise you'd solve it and get x equals some number, plug it back in, and get the y. All right, substitution method. Like number 2, except for we don't have it solved for a y right now. Here's the one that's closest to y, positive 1y. All I have to do is subtract the 3x across, and I have it solved for y. So now I have y equals 2 minus 3x. So now it's just like number 2. So I can substitute that y into that y right there. Okay. Let's change the color. Let's go. So I have -6x minus 1 parentheses, because I'm substituting in 2 minus 3x equals -5. Distributive property. Make sure you distribute through both of them. Draw your arrows. So I have -6x minus 2 plus 3x equals -5. Combine like terms. -3x minus 2 equals -5. Add the, well, if we want to, we could multiply the whole equation by -1. Just switch all the signs. So now I have 3x plus 2 equals 5. Subtract the 2 across. 3x equals 3. So divide by 3 on both sides, and you get x equals 1. So I have x equals 1. Substitute that right into there. And I have y equals 2 minus 3 times 1. So y equals 2 minus 3, which is -1. So that answer is 1, -1, the point of intersection. Remember, keep saying point of intersection. It's a point, so you got to give it to me as a point. Number 4, graphing. I graph these. The first one, m equals 1 over 1, and b equals 0, 4. Remember, to find the y-intercept, we plug it in x equals 0, so then y equals 4. E stands for the y-intercept. So 1, 1, 1, 1, or I can go down 1 and back 1. Okay, so all those points. Okay, next one, change that to a 6. Slope equals 3 over 1. Y-intercept, x is always 0. Plug in 0 and you get 6. So x is 6. If I went up 3 and right 1, it would take me off the charts, so off the graph. So let's go down 3 and left 1. That's still positive 3. So down 3, 1, 2, 3, and left 1. Oh, it's right there. There's my overlap. So what is that point? Negative 1, comma 3. Okay, that's what I should see. If you want to go ahead and draw the lines for them, that's fine. And put arrows at the ends. You don't have to, but it should intersect right there at negative 1, 3. Okay, number 5. Okay, put that as a minus. Graph by intercepts. So x-intercept. Remember, if I'm solving for the x-intercept, that means I have to solve for x, so that means y has to be 0. So if y is 0, x is 1. Y-intercept, if I'm solving for y, then x has to be 0. So if x is 0, y is 1/2. So 1, 0, and 0.5. Okay. Next one. Change the color. X-intercept. Again, y must be 0 because I'm solving for x. So if y is 0, x is 1. Oh, there's my intersection already right there. So I don't even have to do the y-intercept. I already found it right there, 1, 0. Okay. All right, number 6, solve by any method. Well, it's solved for y right now, so I may as well just go ahead and use substitution method. Substitute that in for the y. So I have negative 1x plus 1, substitute in, negative 2x minus 3 equals negative 3. 1 times anything is itself, so I can just take off the parentheses. So I have negative 1x minus 2x minus 3 equals negative 3. Combine like terms. I could multiply the whole equation by negative 1 to switch all the signs. So I like dealing with positives better. Subtract the 3 across. And divide by 3, and 0 divided by 3 is 0. So x is 0. Okay, so again, then I can just plug that in to the x right there. Negative 2 times 0 is 0 minus 3 is negative 3. So y is negative 3. So the point of intersection for this one would be 0, comma, negative 3. Okay. Solve the system of inequalities. Remember, so if it's an inequality, you're going to have shaded, and it could be solid or dotted line. Remember, if it's got an equal sign like that, solid line. It's in slope intercept form, so I just believe what that is right there, which is greater than, so that's above. So I'm going to shade above the line, and it's going to be solid. This one does not have an equal sign, so it's going to be dashed or dotted. I don't care which word you use. And it's below, because it's a less than symbol. So again, I have my slope, because it's in slope intercept form. Identify the slope, 2 over 1. Y-intercept, x is always 0. Plug it in, you get negative 1. Okay, so 0, negative 1, slope of 2, up 2, right 1, up 2, right 1, and it's solid. Arrows at the end. Okay, this one got slope of negative 2 over 1, down 2, right 1, y-intercept, 0 for x, 4 for y. So 0, 4, we'll change the color, 0, 4, and down 2, right 1, down 2, right 1, and this one's dashed. Okay, so graph the two lines first. If you graph those correctly, that's 2 points. Okay. I'll give you a third point for the making it dashed as opposed to solid, because common error for getting to do the dash versus solid. And the fourth point would come from the uh, um, shading. Okay, so on the red one, it is greater than, so it's above and above there for the red line, and it's less than for the green, which is there and there, below the line. So where do I have two dots? Right in this region right here. So that means if I plugged in any number into here, it would satisfy both inequalities. Okay? If I plugged in one in that region, it will only satisfy one. If I plugged in one in that region, it only satisfy one. If I plugged one over in this region, it wouldn't satisfy either of them. Okay? Solve the system of inequalities again using intercepts. The reason you're using intercepts is because it's in standard form. So again, x-intercept, solve for x, so y is 0. So x equals 2. Y-intercept, since we're solving for y, x is 0. X is 0, y would be -8. Okay, for the next one, x-intercept, solving for x, so y is 0, x is 3. Y-intercept, since we're solving for y, x is 0, y is 2. So now we have our intercepts. We plot those. Okay, so 3, 0 and 0, 2 for this one. They're both dashed. Okay, because there's no equal signs underneath them. 2, 0, we'll change the color. 2, 0 and 0, -8 right there. Like I said, they're both dashed. Okay. Now, the short and fast rule, if you don't want to have to solve for y and then put in the slope intercept form like number 7 and figure out the inequality symbol, if I look at the coefficient of y, and if it's negative like it is here, I need to switch the inequality sign. It's positive on this y, so it stays the same. Okay? So both of them are shaded below. So below the green line would be here or here. Below the purple line would be here or here. So where do I have 2? Right there, in that region right there. Okay. Our story problem 1. Jerry bought some tickets for a concert. He bought adult and children tickets. Adult tickets cost $19, $19 for adults, and children's tickets cost $7. He bought a total of 37 tickets for a total of $379. So notice this equation is all based on dollars. $19 for adults, $7 for tickets, and $379 total. That's easy to remember which goes with. And then total tickets, so you have adult tickets plus children tickets equals 37 tickets. These are all tickets. So it's easy to remember for that equation. You're just putting those tickets together. It's always going to be A plus C and then equals the total number of tickets. Okay, so now we need to solve that system. The easiest way is to eliminate the, have a positive 7 multiplied by -7 to get rid of that C. And so I have 19A minus 7A is 12A. And I have 379 minus, I have to do 7 times 37. 7 times 30 is 210 plus 49 is 259. You can just put that in your calculator. And I get 120. Okay, last step, divide by 12. And so A equals 10. So if I have 10 plus children's tickets equals 37, what number plus 10 is 37? That'd be 27. So I have adult tickets equals 10, children equals 27. Okay. Box it in so it's nice and easy to see. And lastly, just plotting points and label them A, B, C, D. -1 means left 1, up 4. There's your A. B says right 2 and down 2 for B. C says left 2 and down 3. Left 2, down 3. C. And D says right 5, up 3. D. 1 point each. Okay. That goes ahead and explains your whole test. So just like it, different numbers.